In this video, we're going to take a look at what the rate of a chemical reaction is, as well as different ways that we can calculate it from data that we've obtained from experiments. So let's start out taking a look at what the definition of a rate of reaction is. Essentially, it's the concentration changes that happen over time in a chemical reaction. So the rate is usually given in, let's put this up here. So the rate is usually given in units of concentration per time. So moles per decimeter cubed per second is a pretty typical unit for a rate. So this is simply the change in concentration over the change in time. So change in concentration over change in time. We can monitor the rate of a chemical reaction either looking at the disappearance of the reactants or the appearance of the products in a chemical reaction. If we were looking at a graph of concentration versus time for reactants, the reactants are going to start out high and then they're going to decrease pretty quickly and then eventually kind of level out here. So we'll see this curve, downward sort of curve with a very sort of steep start and then flattens out. For products, if we look at concentration versus time, we would begin with 0 products. It's going to increase rapidly and then it'll level out over time. So these are the two basic sort of graphs that we would expect to see if we're looking at concentration. Now, rates for reactants, if we're looking at this, they're generally going to be negative because we're looking at the disappearance of those reactants. And the rate for products is usually going to be a positive value because they are starting to appear. There are two ways that we can calculate the rate of change. So first off, we're going to look at the rate of change at any particular time. This is really important because for most chemical reactions, we're interested in the initial rate of the reaction. And that's because this is where the rate of the reaction is the fastest, because this is the point where our curve is the steepest. So if we wanted to find our initial rate, we're looking for the rate at time equals 0 here. To do this, we're going to take a tangent to the curve. So I'm going to do my best here to draw that in. And we're going to calculate the rate based on the slope of this line I just drew in here. So the rate is our change in concentration over our change in time. Let's put this in red. So we'll take this initial point here because that's pretty easy, and we'll take this one down here. So I've got 0.55 for our concentration here and 0.1 down here. And then our time is going from 0 to 3 seconds. So when I do that calculation, I get 0, and this is going to be negative, right? Because we're disappearance of a reactant. So negative 0.15, and then our units are moles per decimeter cubed per second. So we could say that then this is the initial rate of the reaction. If we wanted to find, say, the rate of the reaction at time equals 3 seconds, we do a similar thing. So we take a tangent to the curve here. I'm not drawing it very well, but you get the idea. And then we'd find the slope of this line instead. So that's how you find the rate of change at any particular time. Now, sometimes you might want to calculate the average rate of change for a reaction. So if you're trying to find the average rate of change, essentially you're taking, it doesn't have to be our initial point, but let's just take our initial point. Let's take our final point here. Say we want to find the average rate of change over this 7 seconds. So I'm not doing a very good job of drawing a straight line. You would obviously use a ruler, but we're going to take these 2 points here to do our calculations. So the rate is equal to 0.55 minus, down here it's about 0.15, and then we're starting at time equals 0 and we're going to 7 seconds. So when we do this calculation, we get 0.057 moles per decimeter cubed per second. And so you can see that value is much smaller than that initial rate of change, which was 0.15. So there are instances where you will calculate an average rate of change, but for the most part, you do want initial rates of change for rates of reaction, because as I said, that is the point where our reaction is going the fastest, and so that gives us the best information about what's happening in the system. So that is rates of change for chemical reactions, how we can calculate those values. That's it for this video. We'll see you in the next one.